So we're going to kickstart now with 3 panels for the rest of the day. This is panel 4. As I said last night in the close, with a wonderful title. So kudos to whoever came up with this. It's the good, the bad, and the leaky. And this isn't something that you need to go to the doctors for. It is, of course, talking about water leakage, which, as we heard in the keynote address today from Mr. Amitabh, is a huge challenge across the world. And it's an ongoing challenge, but the interesting thing about this session is it's talking about water loss results. So actual case studies from around the world and speakers to talk about programs that have reduced water losses. So I'm pleased to hand over to our moderator for the session. She's been at Camstrup for 13 years and has held various positions within marketing and sales roles of smart metering solutions for water utilities. And more specifically, over the last 5 years, she's focused on market development and development of global opportunities. So you're in safe hands, great experience globally of the challenges. She has a global panel. And so I'd like to hand over to Lena Warming, who is the head of commercial services within Camstrup. Lena, over to you.
Thank you very much, Tom. Good afternoon, everybody. I'm in the middle of my summer holidays right now, but I mean, what can be more important than fighting water loss? So I'm very pleased to be here and to moderate this session on leakage detection. As Tom mentioned, fighting water loss is one of the biggest challenges in the water sector, and not only it's wasting the resources, it's also produced water that is not consumed and therefore unaccounted for. So and therefore also undermining the financial situation of utilities. So I have a very interesting panel today, consisting of 4 specialists, 3 people from 3 utilities, and finally Pete Dakin, who is the CEO and founder of WordNerds. WordNerds is a software provider, and they are specialized in social listening. And I'm very much looking forward to, and I'm very curious about how social listening combines or goes together with leakage detection. But first of all, we will start with Andrew Donnelly. He's head of leakage management at EPAL Utility in Portugal. Please, Andrew, you can start your presentation.
Okay. Unfortunately, I can't share my screen and I have no video.
Oh.
Okay.
I think you have
yes, now you should be able to. I apologize. Sorry, you just came in under another name. So.
Okay, that's great. Thank you. Right. There we go. So you can all hear me?
Yes.
Okay. My quick presentation to go through what we've done here is about non-revenue water control, but specifically targeted at trunk main leakage here in Lisbon in Portugal. So just to set the scene of where we are and what we do. EPAL is the largest water supplier in Portugal. We do bulk supply to around 1/3 of the country, both geographically and in terms of population. And we also do direct supply to around 350,000 clients, more than 500,000 people here in the city of Lisbon. What we have is what I would call a mature and successful DMA monitoring project, which we've set up progressively since 2005, 2006. We have our own software support system that we've developed internally, and we have our own active leakage control teams who the guys go out on the street to actually find the leaks. The whole project has provided us with enhanced network management, improved resilience, greater diagnostic potential within the network, and what I would say are probably highly positive results. How have we done this? I would call it sort of a classic solution of network metering and monitoring. allows us to identify where the problem is. We then qualify the problem, what is the priority area, and we go out and find the leaks. Hopefully, we find out where it's lost, and then we do some repairs at the end to make sure that it's all resolved. But the challenge is to sustainably manage those gains in water loss control over the years. So, again, just to set the scene quickly, we spent largely 4 years or so, 4 or 5 years, implementing a DMA monitoring system within the distribution network in Lisbon. The results followed quite nicely up to about 2010. Where we ended a very stable period of 5 years ago, where we've got the systems, we've got the tools, we have the data, we've got the staff, steady state, constant performance, and then it all started to go wrong again in 2016, where we started to notice an increasing trend in non-revenue water again. Sorry.
Andrew, if I can just ask the audience to, if you have questions, please put them into the chat, and then we will look at them afterwards. Thank you.
Okay. Thank you, Lena. Because we have essentially a full DMA rollout across the whole city, as you can see from the map there, we were able to quite confidently say that the problem wasn't within the DMAs, but we identified 2 supply zones, which are about 150 kilometers of mains, where the problem was. So we could eliminate 90% of the network and concentrate only on the 10% that was giving us the problems. Yeah. So what we did was we had, and I think most other utilities will say the same thing, that we don't have the same intensity or density of metering and monitoring of our trunk main networks. And as I said, we've got target areas 150 kilometers or so. So how were we going to try and narrow down where we thought the problems were on that trunk main system? And what we did was we came up with a new methodology which we rolled out for this particular problem, where we used our hydraulic model to simulate a series of alterations in the network, where we used DMA meters to temporarily monitor short sections, say 1 kilometer or 2 of these trunk mains. So as you can see from this diagram here, what we did was we opened the boundary valves between a couple of DMAs, continued to feed the DMAs normally, but we reversed the flow through 1 DMA meter with closed valves, which allowed us to estimate the volume of losses on a relatively short section. The table on the right shows all the tests that we did, and it's quite obvious that there's 4 or 5 different sections that were needing some specialist leak detection interventions. So instead of having to cover 15 or 20 kilometers of mains with this, what are expensive and difficult inspections to set up, we identified only the critical sections to do this leak detection on. So where we could, we did normal leak detection using standard correlation and geophone methods using company resources. We then planned and then implemented a Sahara campaign via Shylon and WRC, and a smart ball trial as well. So the smart Sahara campaign was very successful. We identified 26 leaks on the 11 surveys that we did. As you can see from the table there, it did take us quite a long time to actually successfully do all the repairs of the leaks which were identified. Most of these being outside of our control. These trunk mains run underneath the main streets and motorways within the city. Neither the council or the police are going to let us go in quickly to do those repairs, and that's why it took us so long to do them. Factors which are outside the control of the company. The smart ball repairs were done as well, but the smart ball had to be done in connection with other leak detection techniques to actually pinpoint the leaks. But the results were remarkable in that the non-revenue water in the 2 critical supply zones were reduced by 20 and 45%. And that's equivalent to around 2 million cubic meters of water lost from these activities. So the result of that was a very positive impact on overall company water balance. So excuse me, in the future, what we would do. We've identified some areas where some additional trunk main meters would be more, would be nice to have in a few key points to help us with these temporary metering strategies. We use offline leak detection sensors, which are deployed routinely more than they ever were. We're developing these temporary monitoring zone plans for all of the non-DMA mains, where we can then repeat them on a regular basis. We're going to repeat in-pipe specialist leak detection campaigns again on a regular basis, given that there's a clear cost benefit for them. And we were well on our way with the 2020 campaign, focusing on the trunk main system, when of course the virus crisis came on us. So thankfully we haven't had any big problems, main operational problems this year so far, but the plan is to, as soon as the conditions allow us, then we'll roll this plan out towards the end of the year or the start of next year. So the results speak for themselves. Again, we've reversed the trend. We're going back down, back non-revenue water again down to values below 10%. So even though we identified a potential problem, I think we had a positive response to increase our non-revenue water problem. We've continued the fundamental DMA work and active leakage control and network monitoring using the established teams. It's quite clear that we can't relax from doing any of that fundamental work. And we've had significant results, limiting the impact on the network, and with the very restricted human resources and finances that we have available at the time. So it was a very targeted solution for what we'd identified as specific non-revenue water origins, which we'd identified. So yeah, we're talking about smart solutions, smart water systems, but I think what we've said, I was too much in my presentations with this phrase, that I think what we've come up with is common sense solutions, but smart people. What really is the most important element within our smart systems? It's smart people, it's us, it's ourselves, and especially with the events of this year, we should value ourselves and our resources and our teams ever more so, given the challenges that we've been unexpectedly given this year. Okay, so hopefully that is my quick presentation. Hopefully that made sense. Lena, back to you.
Yes, thank you. Thank you, Andrew. I think it was a very interesting presentation, especially your final comment about the smart people, not just smart systems. I mean, but how do you make sure that to support the competence building and also the staff development within the utility?
This is it's a very pertinent question, and it's an issue that has been of great concern to us since we started the project. Is investing in people, and I think part of the success of our project is probably not a great secret, but it's keeping the same people in the team since we started. I've been in the team, well, I've been in the company now for 15 years, and the same people who've been working with me for 13, 14 years are still the key members of the team. So it's the guys who have helped me set up the monitoring system. They've designed all the DMAs, installed all the equipment, set up the DMAs, and for 10 years or so they've been looking at the data. So all that inherent knowledge that we have has remained within the company. And I think that has incredible value to the company, especially during the crisis of this year as well, where we've already got that all knowledge in-house. Yeah.
Okay, thank you, Andrew. Thank you very much. There are some other questions, but I think right now we would jump to Arik Mullah from Israel, from Meishikma Utilities, and then we will wrap up with all questions at the end of the presentations.
Okay, can I start? Do you hear me?
Yes, please. Yes, please, Arik.
Hi, everybody. Good afternoon from Israel. In my presentation, I will show you another benefit that we can produce through leak detection sensor. Meishikma is a water and sewage utilities which serves 4 municipalities, and we are located south to Tel Aviv. We serve about 250,000 citizens and about 100,000 of customers. We buy about 20 million cubic meters of water per year, and our non-revenue water are about 7.5%. We started at about 20 or 25%. Our annual budget is about $50 million, and we maintain about 400 water pipes and 400 kilometer water pipes and another 400 kilometer of sewage pipes. In Meshikma, we are adopting new technologies. We use such as leak detectors that I will speak on it later, and many technology of water quality monitoring, sleeving technologies, smashing technologies, and micro tunneling. We plan and practice a lot of water distribution during an emergency times. In our project, we installed about 750 acoustic sensors over the water pipes. These detectors are monitoring the water pipelines and located the exact position of the underground leaks and the leak size by the level noise which it makes and its evolution. During 2019, we located and fixed about 150 leaks. On this map, we can see where the leaks are located. Aquarius Spectrum developed a new innovation solution to assess pipe conditions based on the acoustic detectors and big data analytics. We took from our call center all the leaks that we had in the last 4 years and positioned them on the map. Over this layer, Aquarius put all the leaks which the system found by the acoustic sensors, and the outcome of all this is a map which shows the pipes conditions and the poor pipes sections which should be renewed. The system ranked them and marked them by red color. You see in this map the red pipes which are in bad condition. On the right side, you can see the evolution of a leak, and the system use this parameter also to rank the pipe condition. In our dashboard here, we can see the results of this project, and we can see that most of our pipes are in a good condition, in green, yellow, and orange color. And we have about 2 kilometers of red pipes, which are in a bad condition, and they should be replaced immediately. This pipe ranked, as I said, by red color, and it ranked by the amount of leaks per kilometer of each section. We can see that some of the poor pipes were installed only 20 or 25 years ago. What we get from this project? By using this module, we now replace pipes according to their actual conditions rather than their age. It helps us to plan our budget and allocate it exactly where it most needed. We don't lose our budget and don't change unnecessary pipes that are in good condition. We reduced the non-revenue water the last year by 10% by acting in this model. Thank you. And if you have a question, I can answer.
Thank you very much, Arik. A question from my side would be, these sensors, are they in a fixed installation, or do you move them around? And second, are there any limitations to, I mean, pipe material and also pipe dimensions?
Okay, we use this detection. We fix them. We are not moving them their location, but there is a possible to move the sensor where you want. But we use we bought 750 acoustic sensors, and we spread all the pipelines by them. These acoustic sensors we use them for metal pipes and asbestos cement pipes, and we have another. We can use another acoustic, hydrophonic acoustic, to find these pipes, the PE pipes, PVC pipes, and the large diameters pipes. These kind of lines we are using the hydrophonic sensors. That's all. Okay, so you have several options yes. or solutions to monitor. Yeah, sure. Okay. Good. Thank you very much, Arik. Please put your questions in the Q&A or in the chat, and then Arik or we will come back. Arik can answer them right away, or we will come back to them later on. Okay. Let's jump to Wasim Khan from PUB in Singapore. Are you with us, Wasim?
Yes, I am.
Hi.
Hi, sorry everyone, my camera isn't agreeing with me, so to make do with hearing my voice.
Yeah, fine.
Good day to everyone. I'm Wasim Khan, and I'm going to share with you a case study on a transmission pipe leak monitoring system that we have implemented in Singapore. I'll be going through three broad topics in my presentation: the system design, performance, and learning experience of the leak monitoring system. And I'll also take some time to share with you a little bit about Singapore, PUB, and what our next steps are. Singapore is an island nation situated in Southeast Asia. Despite being an island nation surrounded by water, Singapore is ranked first among countries at the highest risk of high water stress by 2040. Hence, you can see water is a precious resource here in Singapore, and why we have to make every drop count. PUB, as Singapore's national water agency, is in charge of managing the entire water loop. This encompasses sourcing, collecting, purifying, and supplying drinking water, to recycling of used water by treating it into new water. Singapore has four main sources of water, or what we like to call four national taps: imported water from our neighbors in Johor, rainwater collected from our local catchments, seawater treated in the desalination plants, and used water treated in the new water plants. In September 2017, we started a project to install 120 leak monitoring sensors along water transmission pipelines around Singapore. We wanted to find leaks as early as possible to reduce water loss. The intent is to locate leaks early when they are small, similar to what you see in the picture, so that corrective action can be taken sooner. The leak monitoring system itself consists of four main components: the processor unit, this is the unit that handles the data, a hydrophone sensor which records the acoustic data, a battery pack which powers the entire setup, and an antenna that transmits the data collected to back-end servers for data processing and analysis. All these components have a really small footprint and can be housed within a chamber. The system works minimally as a pair, and the more sensors you add on, the longer the stretch of pipe you can monitor. Typically, each sensor configuration is spaced on average 750 meters apart on existing appurtenances. The longer the spacing between each sensor point, a lower sensitivity is expected, and the shorter the sensor spacing between each sensor, a higher sensitivity can be achieved. The system works similar to a leak noise correlator, but instead of having just 2 or 3 points for correlation, multiple sensors come alive at night to analyze the acoustical properties of the pipeline. Back-end analysis then determines if a leak is present on any segment. If there is, leak alerts are sent to PUB staff for immediate action. Therefore, every day, in just a matter of a few minutes, the areas which have these sensors on them have been checked for leaks. As I mentioned, an antenna is required for the system to send the collected data through a 3G network. There are a variety of options available which can be utilized in various environments. The antennas can be customized to fit chamber leads where necessary. And one we have here, for example, by the side of the road in Singapore. Once we got the system in the ground and it started finding leaks, we needed to determine the effectiveness of the system. The project team decided on a unique 2-metric system to determine just that. We decided that we needed to determine how well the system detected leaks, which is a ratio of the leaks found against all the leaks within the monitoring segment. We also needed to determine the classification performance of the system. What this means is that we wanted to know how well the system was able to distinguish a leak noise against other noises that were being picked up. Naturally, in a water system, there will be background noises, and the system needs to be able to distinguish between all these noises. By viewing these 2 metrics together, we were able to determine the leak monitoring performance of the leak monitoring system. After 3 months upon system commissioning, we saw 100% for both the detection performance and the classification performance. And this was somewhat expected, as there would have been initial background leaks in the monitoring zone that were previously not picked up through our regular active leak detection program. So as you move along the project to 12 months and 30 months in, you see that the numbers change. So far, what we've seen is that the detection performance has been healthy, though the classification performance needs to be improved. Some learning experiences to share with everyone. There are advantages and limitations that revealed itself as we moved along the project. The clear advantages of the system are that the system is able to detect leaks on large diameter pipelines, which traditionally was hard to do. It has allowed us to reduce our awareness and leak detection time. In essence, the leak runtime is reduced, and so there's a reduction in water loss. We are also able to house the system within existing appurtenances in our network, so less civil cost is involved in actually putting the system in. There are some limitations. The system is unable to pick up small leaks as the sensitivity is limited by the sensor spacing. And it is also unable to detect a leak outside of the detection window in which the system is programmed for. Of the 3 leaks that were missed, we believe that the leaks had formed outside the detection window. Another limitation that we had encountered is when we used an invasive tool within a stretcher pipe that had the leak monitoring system on it, the tool was able to pick up leaks that the system had missed. The vendor tells us that the leaks were deemed too small to be picked up by the system. Moving on from this project, we've seen tangible benefits in having a permanent monitoring system within our transmission network. Therefore, we are looking to cover 100% of our transmission network over the next 2 years. That being said, we are actively looking and welcome new and upcoming monitoring technologies to achieve this plan. I've come to the end of my presentation. Thank you very much, and back to you, Lina.
Thank you, Wasim. A question comes to my mind. How do you work with the leaks within that are outside, within the limitations? do you add another detection solution, or do you just live with that?
So we have to explore various options, one being the possibility of installing more sensors to try and increase the sensitivity. The other being we ramp up our active leak detection program on those segments. So we'll try and go in biannually to see if those pipelines are leaking or not.
Okay. Thank you, Wasim. Also, does the system work with all kinds of materials, like metal, PVC, PE?
Yes, my understanding is that the system works well with all materials. There are limitations, however. Plastic, for example, you need a reduced sensor spacing, so you want shorter segments. Whereas for metallic pipes, you'd be able to go longer distances, up to that 750 meters that I was talking about.
Okay. Thank you, Wasim. We will come back to questions in the Q&A later. Okay, finally, we have Pete Dakin from Word Nerds. Hi, Pete. I don't think we can hear you.
I knew I was going to be the person that did that. Is that better?
Yeah, that's much better.
Awesome. Right, great. And hopefully you can see my screen as well.
Yes, we can, for sure.
Right, well, thank you very much for inviting me on. Hello, everybody. You're about to get 8 minutes of something completely different from the other three panelists, all of whose exposition was, I think, really, really interesting. So if this is a bit different, bear with me. I hope it's interesting. So my name is Pete Dakin. I am CEO and co-founder of Word Nerds. And the problem that we solve is a problem of too many words. Large organizations, utilities businesses, and water companies in particular have all kinds of words floating around the business written by their customers and written by their members of staff. That can be in CRM systems, it can be in social media, it can be on forums, it can be on review sites, news articles, all kinds of areas. And the tools that historically we've had to make sense of these words have not always been good. I'm sure all of you have used word clouds before. Word clouds look extremely pretty, but they are almost completely useless to humankind. They don't actually tell you anything and give you any data that is actionable. And why would they? Because the problem that word clouds don't address is that language is pretty weird. Young people use language extremely differently to older people. There are huge regional variations, even within countries where there are whole different words that mean different things. People are ironic, sarcastic in the US and the UK. People often write the exact opposite of what they mean and expect us as humans just to kind of understand that. And don't even start me off about spelling, punctuation, grammar. I don't know what our kids are doing at school these days, but it certainly isn't what we used to do. So above all else, though, words mean different things in different contexts. So you can take exactly the same word and you can put it in a different sentence and it'll mean something else. The examples we like to use are outstanding and sick. So outstanding is a hugely positive word, but not in the context of debt. Outstanding debt is the worst type of debt that we know that we can have. Similarly, during a global pandemic, none of us want to be sick. My 12-year-old daughter, everything she listens to on Spotify is sick. Everybody she hangs around with is sick. It's sick this, sick that, and I'm really cringe, apparently. So there you see there's some examples of different words in different contexts meaning different things, and word clouds and the old ways of understanding these make no sense. Similarly, having sentiment analysis as a tool that effectively counts the number of happy words and counts the number of sad words and gives you a score, doesn't tell you about the nuance of a sentence, because actually people are often polite and they say things like, hey, water company, your engineers are really nice, but they're digging up the street outside my house and I can't get my car out of my drive. There's positive things in that sentence and negative things, and without understanding the way that all of those words link together, you can't possibly pull out what is positive and what is negative. So how does Word Nerds address that problem? We come to this not from a data science perspective first, but from a linguistics perspective. My co-founder is a linguist, and we are really interested in all of the different ways the language fit together. And we've taken all of the learnings that we have from things, really old technologies like corpus linguistics, and then we've really fed that into really new technologies like neural networks, artificial intelligence, and computer machine learning. And we've developed a context engine, a SaaS platform that takes inputs from a variety of sources and pulls it into a central cloud-based platform that allows us to segment data by meaning. And this is the key thing that we do differently. And I'll show you an example of it. It's a bit sweary, so apologies in advance. But I'll show you an example of it in a second. And what we allow you to do is we allow you to find people who are expressing exactly the same problem, even though they may be using different vocabulary to articulate it. What do I mean by that? You might say, there is a leak on the street outside my house. I might say, water is gushing from the road where I live. We're both saying exactly the same thing, but the vocabulary that we're using is completely different. And if you're trying to use social media to find out what your customers are saying, either as an early warning system for problems or retrospectively to look at how much of an issue something is, the different languages, unless you can reconcile the different ways people use language, that's going to be difficult. And how does that manifest itself as an output? Well, we have two things that we do. We have alerts. So, for example, in the case of leaks, if a water company wants to listen to social to use their customers as sensors and find out how quickly people report leaks, as soon as something comes up that matches a leak report, we can send that to an engineer, or we can do it as a report. So we can say, right, over the last 30 days, 60 days, whatever it is, the things that people are saying about your company are this, and the things that people are saying about your competitors are that. So how does that work? So here's just a 10-20 second video of our system. What we've got here is you put in natural language of the things that you're looking for. So this is an actual tweet that somebody put the other day from a water company. The system finds things that are like this, but are using different language. So you can see here, we've put in about water going into the way, we've got water gushing, my street is flooded, all kinds of different ways. The AI picks this up from its contextual understanding of language. And then you can train something in real time to say, yes, this is something that we're interested. No, this isn't. You retrain the model, and then that model will then reduce that data set so it just contains stuff that you care about based on what people are saying, not how they're saying that. And I've got lots of percentage figures there and graphs to show how accurate we are. So because it's graphs, it must be true. What does that mean for leakage? Well, we started looking at leakage with a company called Northumbrian Water in the northeast of England a couple of years ago, and we did some really early detection work. We looked at all the different ways that people were using our context engine. We looked at all of the different ways that people were reporting leaks, and we started setting up alerts for it. And we found really quickly that two things were happening. Firstly, when people saw big leaks or any kind of leak, they were telling the water company directly. But actually a large proportion of people were reporting the leaks to other people, not to the water company themselves. So a lot of these leaks were going undetected. In this example here, somebody sees a leak in Newcastle, a city in the northeast, and at 2:37 p.m. they report that to the council, not to the water company. At 3:32, Newcastle City Council get in touch and they go, oh, this isn't our problem, you need to speak to Northumbrian Water. Brilliantly, that is not Northumbrian Water's Twitter handle. That's somebody else's Twitter handle, and the water company could do nothing with it. The customer is the person that finds this out when they look into it. They then copy in Northumbrian Water's handle. This is at 4:21, and by 4:34, an hour and 53 minutes after that leak was reported, Northumbrian Water find out about it. They take the address. It wasn't something that they were aware of, and they send engineers to go and fix it. So that's 2 hours. And in a trunk main leakage, when there are megalitres of water per second leaking into the system, a 2 hour window could be extremely kind of important if you could truncate that. What was really interesting was then when we went back through the Twitter data, we found that exactly the same leak had been reported 24 hours previously. So somebody had seen the beginnings of the same leak the day before, and again, they'd reported it to the council, not to the water company. And when we showed Northumbrian Water this, they took our solution in, they set it up listening for leaks, and they've been using it ever since, and we've developed a really fantastic partnership with them. Leak detection, customers as a sensor is one usage of this thing. I'll very, very quickly mention some of the others because I know that some people in the round table were interested. One of the big problems that UK water companies face at the moment is that they are being financially incentivized and measured through something called CMEX, so what their customers think of them. And it's really difficult to build a brand in a world where people only ever see you in stress situations, when there's a shortage of water, when there's, you know, restrictions on what people can use, or when you're digging up their high street because there's been problems. One of the things that our technology allows them to do is find conversations that they're interested in, that people don't think they're interested in, as a way to either brand build, make connections with people, or answer problems that they've got. We had a great one during COVID where supermarkets ran out of toilet roll and people started flushing all kinds of things down the loo. That led to sewerage blockages. So Northumbrian Water started using our software to find people who were talking about supermarkets running out of toilet roll, and then they would preemptively get in touch and said, you know, that's really sorry to hear that, that's awful, but please don't flush anything else down the loo, no wet wipes, no newspapers, this is leading to blockages. And they reduced the number of blockages that they've had. So we've got all kinds of use cases for opportunities to delight market research, campaign support, and individual issues. And if you're interested in finding out more, we've produced a State of the Nation report, a summary report. It's really quick to read, really interesting. My contact details are here. Please do get in touch. Be really happy to share this with you so you can see what all of the major UK water companies, customers have thought about their experience during COVID. Lena, back to you. Thank you. Haha, now you're on mute. You've done it too. It's catching.
Thank you very much, Pete. I think that was very interesting. I know now we are short on time, but I just have a couple of questions. Do you see this as an add-on to a traditional leakage detection solution, or do you see it as a standalone, the only solution for utility?
I think I really enjoyed the conclusion to Andrew's presentation earlier, where he said that, you know, we all talk about smart systems. You know, we all talk about artificial intelligence. That's the buzzword in my industry. Actually, natural stupidity is equally as important. Human beings and our application of these technologies is more important than the technologies themselves. Most people we deal with have data coming up the yin-yang. They've got more data than they can ever process, more information than they ever actually do anything with. And actually using this data smartly, layering some of these technologies and some of the things that Wasim and the other guys have been sharing with us, all of this stuff is available. And why wouldn't we use as many of it as makes sense in our own individual use cases to give us as full a picture as possible? But the key isn't the technology, the key is in its implementation. We've used our stuff with one company who've had amazing results, and exactly the same stuff in exactly the same use case for other people that just haven't implemented it as well. It's only as good as the human beings behind the keyboard.
Thank you, Pete. I have one question from about asking for your for the YouTube link. Maybe you can share that somehow.
Yeah, I'll share the link to the report, and I'll share my contact details as well. If anybody wants to get in touch, I'd be delighted to speak to you.
Yes, and then I have another question. Great thing. How do I deal with knowledge, though not verbalized?
Hang on a minute.
I don't know how to understand that.
Let me have a look.
It's a question from Adi Levtov. Please, if you could elaborate, but we really do not have a lot of time.
How do you deal with knowledge not verbalized? Is machine learning getting the meaning out of text? Okay, so I think this is a question about what machine learning can and can't do. So machine learning is really good at telling you words that are linked contextually. What it's not good at is understanding language, and that's where you need the linguistics layer. For anybody who understands natural language processing and is working in this space, things like Google BERT and some of the latest natural language processing engines are really, really good at getting you 2/3 of the way there. But it's the old technologies, it's the corpus linguistics that you need to actually apply understanding to that. And that's probably the unique thing about our technology that allows us to be able to say, these two people are both talking about leakages as opposed to buying leaks from the greengrocers. And you can see where with misspellings and things that could become an issue.
Interesting, very interesting. Okay, I think we have to wrap up this session. I thank the 4 panelists for their presentations. Very interesting, and I hope that you have the possibility to stay in touch with the participants going forward and also during the conference. So I will hand it over to Nadia, and now you can have a 5-minute break. Thank you.
Thank you, Lena, so much for hosting such an interesting and diverse panel, giving us this these various global perspectives on how to tackle this challenge of water leak. We will be taking, thank you again. We'll be taking a short break. And for those of you who've been enjoying the fact that we're recording everything and popping out for breaks, and if you don't need to leave now, we have a wonderful sponsored video by Jacobs that we'll be playing during the break. Otherwise, if you leave, we'll see you back at 20 after to resume.
Really interesting discussion so far. And I think for me, what came out of the last panel was it's still about the people, the smart people it was referred to. And I think interesting points from Portugal that around staff retention, if you've got the same team that create the DMA, monitor and analyze the data from that DMA, it can really lead to some interesting results. So we've looked a little bit on the drinking water side, and now we're going to move on to wastewater. And the session is next generation wastewater management, machine learning, optimization and automation. It's hosted by a guy who I think arguably has one of the best names of all the moderators, but I am a bit biased. And Tom Woolley is a business development director of Royal Haskellingh DHV. He joined the company in 2018 to lead the expansion of its AI-driven technology AquaSuite into the UK, North American and Indian market. So again, really interesting international experience, and he has 15 years experience within the smart water and intelligent control sector, and before that even more international development. So Tom, if you can come in, I'll hand over to you.
Thanks, Tom. Thanks for the introduction. Definitely agree on the name, thank you. Yeah, so as Tom mentioned, this is the session, I think the only session actually, where we're primarily focusing on wastewater. Going back a number of years that I've attended SWAN, there's been a real focus on smart water and smart solutions and so on. And a little bit, certainly at the start, wastewater was kind of a forgotten area. And I think as stuff moves on, as the world's turning and we're starting to see more and more issues around availability of water, people are starting to look more and more about the water that we return to the environment. And there's an interesting movement and something I really like to see, where wastewater treatment sites are no longer being called wastewater treatment, they're actually being looked at as water recycling centres. And that's really great to see that we're really focused on the water we put back to the environment and how we can reuse that in the future. And we've got 4 great presentations, 5 panelists, but 4 presentations. 2 of them are joining together. And we're going to hear from 4 people who've got great projects where they've deployed, implemented smart solutions in the area of wastewater. And we're going to hear about the advantages and the efficiencies they've derived from those. We are going to start with Javier Garcia del Rio. He is a telecommunications engineer by background with a master in water cycle management, and he's currently coordinating automation and instrumentation at Canal de Isabel Segunda. Apologies for any pronunciation errors, Javier. Canal de Isabel serves water supply to around 6 or 7 million people in Madrid, but also offers services in Latin America. And Javier is going to share some of his experiences. Javier, over to you. I think you're still on mute, Javier. Excellent. Away, after you, Javier.
Can you see my screen?
Yes, we've got it. Thank you.
Okay. Okay. Hi, everyone. First of all, I would like to thank the organization for the invitation to this forum. It's a great pleasure for me. I'm Javier Garcia del Rio, Canal de Isabel Segunda's Digital Transformation Manager. As most of you know, and as Tom said, Canal de Isabel Segunda is the company that takes care of the complete water cycle in the region of Madrid and supplies more than 6 million customers. Canal de Isabel Segunda started a strategic plan with Horizon 2030, organized into 10 main lines, containing some strategic plans which gives the company's roadmap. The digital transformation is one of those relevant plans. It's part of Line 9 of innovation and development. The companies that manage water are the first to face this forced transformation. There is first by obligation. Many countries suffer the demographic increase. The lack of drinking water and sanitation can be the most serious problem on the planet, not to mention climate change, which is also part of the water cycle. Water companies have the responsibility to innovate, to be more efficient in the management of such a limited and essential resource. And second, for opportunity. As in the rest of companies, we have the common advantages, optimization of processes, economic efficiency, and improvement in decision making. The digital business strategy must be divided into some vertical branches to facilitate its management and the integration in the company. The first one is culture of digital transformation. Within this branch, it's considered essential to measure the degree of digital maturity, to know the current situation and discover opportunities for improvement in processes and services thanks to the use of digital technologies. In Canal de Isabel Segunda, we have developed a digital maturity indicator for water management companies, which evaluates, among other things, whether a facility, for example, a wastewater treatment plant, has an optimal level of automation and digitalization in order to manage its processes and services efficiently. The second branch is digital transformation by information technology, regarding the development and support of corporate and cross-cutting services, fundamental competence of the information technology world. Canal de Isabel Segunda is working in the development of vertical and horizontal integration of systems, implementation of a global CMMS maintenance system with the possibility of integration, for example, BIM modeling. An example of this branch is the energy efficiency scorecard for wastewater treatment plant, in which the measures of the electric meters and the most important hydraulic parameters of operation are integrated to know the energy ratios of each facility. Water Industry 4.0 by operation technology is the third branch. In this modern era of new digital technologies, industry is immersed in a transformation at the level of previous industrial revolutions. The water industry is no exception. This fourth industrial revolution is the result of the implementation of digital technologies, intelligent automation, and total connectivity in industrial processes. One of the projects of this branch is what we've called the wastewater treatment plant of the future 4.0, in which new technologies are incorporating, such as simulating of the processes, segregation of energy consumption, DMZ for industrial cybersecurity, automation system, advanced communication, sending data to the cloud, for example. Connected client or connected user is the last branch. The distinguishing point of this fourth industrial revolution compared to the previous ones is to place the user at the center of the business. An ambitious ongoing project is the integration of mobility solutions for field operation and maintenance. Also, get connectivity to external partners like universities, research centers, to improve the performance of wastewater treatment plant industrial processes. In this regard, one of the applications of this digital industry transformation that will be the future of facility management refers to the hyperconnectivity of systems. Canal de Segunda has developed a high-efficiency telecontrol architecture, a mixture between a SCADA-based remote control system and cloud-based architecture that allows the integration of signals from any automation system and connectivity to and from information, operational, and business systems, respecting at all times compliance with the company's cybersecurity standards. The design cloud-based platform allows data monitoring, dashboards creation, information analytics, application development, as well as connectivity between systems. Canal de Segunda is developing business value application with this concept. Another project example aligned to this architecture is called Hermes project, through which a cloud application has been developed that allows management of wastewater treatment plant sludge. The inputs are the signals of the level sensor of the wastewater treatment plant hoopers, regardless of the manufacturer or PLC system belonging to OT, operational technology. And the resulting outputs are work orders in mobility for the removal of sludge, orders integrated in the Canal de Segunda's maintenance management system belonging to IT, informational technology world. The application is even being developed to achieve optimization of the routes of sludge removal trucks, in the case of visiting several facilities on the same day, and with the sending of industrial process alerts to the technicians to mobility work orders. These are some projects of digital projects of Canal de Segunda, and if anyone is interested in get deeper information about the projects that I presented, don't hesitate to contact me in email or question panel. In conclusion, it's important to be up to date with main technological trends related to digitalization and Industry 4.0 to transform data into value. Thank you very much, and Tom, I give you the floor.
Thank you, Javier. It's really interesting to see some concrete examples of how people are using data and machine learning and dashboards to improve performance. One thing I did forget to say at the start, if anyone does have any questions, please put them into the Q&A box on your screen. If we have time, we'll answer some of them as a panel at the end. If not, I'm sure my fellow panelists will reply to you via the chat functionality. Next up, and this is a name I will apologize in advance for getting wrong, because it's really difficult for me, is Perttu Saarinen from HSY. He's an automation engineer at the Helsinki Regional Environment Services Authority. He's been there since 2012, I think, at the start of his career. And HSY provide high quality drinking water to over 1 million people in Helsinki. Perttu, if you are ready, I'll hand over to you.
Yes, thank you, Tom. So hello, everybody. I am Perttu Saarinen, and first of all, I would like to thank you for having this opportunity to be a part of SWAN 2020. Really excited for this. So my topic for today is from decentralized data to holistic management of wastewater networks. I work as an automation engineer at HSY, and HSY was founded in 2010, so it's our 10th year anniversary this year. We have more than 1 million customers, 3,000 kilometers of wastewater network, and more than 600 pumping stations. We are located in Northern Europe. Our operating area is the capital Helsinki and the neighboring cities Espoo and Vantaa. We are gathering a lot of data from the wastewater network. For example, pumping stations flow data, energy consumptions, weather data from the Meteorological Institute, and we have a lot of IoT sensors in the sewers as well. The problem has been that the data we have been gathering was spread around in different systems and subsystems, and it wasn't really easily accessible even for ourselves. And obviously we wanted to use this data to manage the network in things like targeting our renovations and dimensioning the pipes and pumping stations. And at least before 2016, this wasn't really happening too effectively, at least. So the answer to our problem was NeuroFlux. Actually, at 2016, HSY held a hackathon event from which a startup company was founded. And ever since then, we have been working closely with NeuroFlux, developing an integrated smart water platform. This platform works on top of an existing SCADA system, and also other sources of data can be integrated through APIs. With this platform, water utilities such as ourselves can start to make use of their data more efficiently. The main functions of the software are proven methods to utilize the data from the wastewater network. Things like automatic blockage detection, detection of infiltration and inflow, data correction, data validation, and energy efficiency calculations, for example. And I would say one of the most helpful component of the software is that it automatically searches for the anomalies in the data for the end user. So the end user doesn't have to go through all the data manually, which is of course impossible. So the software picks up the interesting stuff and we can focus on that. So that obviously saves a lot of time. Here I have a few case studies. In this first one, we have constructed a baseline from the history values of a pumping station's flow. And when constructing these models or baselines, the data validity is crucial. So the raw data that is being used is gone through a multiple steps of filters and such before we trust it to be good. So the software has detected a deviation from this baseline, and it has set up an alarm which the end user gets and can then analyze the situation and further investigate the situation in the network as well. And in this case, there was a blockage in the sewer which we were able to locate and open. So this matter was dealt with. The second case is kind of the flip side of the coin. Excessive water has been started to come to the sewer. And again, we are getting an automatic alarm for this, and we can start to investigate what is really happening and where this water is coming from. After some small investigations, we have been able to locate a clean water leakage straight into the sewer. And since we have been able to fix it. And this is something that happened just last month. So these are all real events from the sewers. And it's good to remember that these kind of events can go unnoticed for a long time if we don't pick them up from the data. And this is what NeuroFlux is doing for us automatically. The third case is a correlation between sea level and flow levels. So we are getting the weather data from the Meteorological Institute, which includes the water levels, for example, sea level. So we can easily find the correlations between the pumping station's flows and the sea level or other water levels. And when we find this kind of correlation, it's quite obvious that the sea is actually leaking into the sewer. But the good thing is that after knowing this, we can target renovations to this area and fix these leakages into the sewer and fix this whole problem. So overall, we have reduced the amount of overflows and also reduced the amount of infiltrated water into our network. And this is actually all done with the data we already had. We just needed to use it more effectively. And Neuroflux has been a great tool for that, indeed. And that is my presentation. Thank you. Looking forward for any questions later on. And now taking it back to Tom.
Thank you, Perttu. It's really interesting. It's an area that I find of particular interest, how we can understand what's happening in our sewers, because they're a particularly difficult place to understand and measure what's happening. So really great to see a concrete example of how people have used data in sewers to prevent problems. Our next presentation is coming from James Devereux from United Utilities in the United Kingdom, Michelle Aguilar from Vapor in Australia. I hate to think what time it is for Michelle, but hopefully she's wide awake and ready to present. Just to give you a bit of background, James is a drainage strategy analyst at United Utilities, and he's been there for over 10 years, I believe, and works within operational services, specialising in civil engineering, geography and geology. He's also a member of the UK and Ireland Sewer Rehab Group. Michelle is co-founder of Vapor and technical lead, and she has a background in software programming, mechatronics and intelligent systems. And I will hand over, I'm not sure who's going to start, whether it's Michelle or James, but I'll hand over to whichever one of you is ready to go.
Yeah. Thanks for that, Tom. I'm just sharing my screen now. So yeah, as Tom said, I'm the CTO of Vapor. We're an Australian company and we are coming out with a mission to automate fault detection in infrastructure. We've been lucky enough to work with United Utilities, who are one of the biggest water utilities in the UK. And I'm presenting alongside James Devereux, who's a drainage strategy analyst for United Utilities, who I'll hand over now to give you some background on our work together.
Thanks, Michelle. Hi, everyone. I think I'm going to start with I'm a bit of a self-confessed nerd when it comes to sewers, and I'm here to talk about what the need is here for the industry. So a good place to start, I think, is a bit on let's do sewer networks 101. Oh, Michelle, we've skipped a slide.
Right.
Thank you. So sewer networks, for those who don't know, these are inspected using cameras, and this is what we know in the industry as a CCTV survey. And these things have been about since about the late 1960s, the technology first came about. And it's recognised now as the worldwide industry standard, really, in understanding sewer network pipeline condition, primarily on gravity sewer networks. And this standardised coding, again, worldwide, that is used to understand the structural and operational defects in a pipe. So what's the problem with that? Well, it's the use of that data. This data is really important for any utility provider in understanding the condition of their network and building a robust asset management plan. So we start to look at the data itself. To code a survey is a very time-consuming manual process, and even if, like me, you do enjoy watching the videos, after a while, autopilot starts to kick in, and you can miss that important defect. But there's a bigger problem here with CCTV, and that's the coding itself, is that it's subjective on the user. So we've got an example here on the screen, and just consider this, that you could have two operators sat in the same room reviewing the same footage, and they may code the defect that they see differently. So on the left here, we've got an example from a CCTV survey that an operator has coded as a hole and broken pipe, which is a structural defect. On the right-hand side is where it is actually coded as a connection, albeit slightly defective, but a much lesser importance of a structural defect. that's the kind of thing we need to take into account here. So I suppose the questions are, yeah, what defects are missing? Investment in sewer networks is limited. We need to ensure that we're making the correct investment decisions based on that data that we have. So the big question for us at United Utilities was, how do we improve the data? So a bit about United Utilities. We're the water operator for the northwest of England. We serve about 7 million customers, and we have over 77,000 kilometres of sewer network to maintain. Put in context, that's enough to go around the world twice. And on average, we survey about 1% of that sewer network each year, and that's broken down to different aspects of surveys ordered by different teams. A large percentage of that is coded surveys, which makes a really important part in us understanding our asset condition and formalising our future asset management plans. But we also have a large amount of uncoded survey data, and this is simply video footage of a camera traversing down a pipe. Whilst it can tell an operator what might be going on, there's a lot of important data there that is getting wasted, and this is something that obviously we're quite keen on how to unlock. We spend about £3.5 million a year surveying sewers. And within the business, we've got a real desire to move to what we call a systems thinking approach. And we want to unlock the value of all of the data that we use, particularly here on CCTV surveys, making sure that the data we have can be used business-wide, is centralised, well-structured, and can hopefully move us towards making more machine-led decisions and remove away some of that subjectivity. So that was the problem and the business case for United Utilities. So we got a call out through our innovation lab, and that's how we found Vapor. So I'll hand over now to Michelle to explain what they do.
Yeah, so last year, Vapor was one of 8 companies out of over 100 submissions that made it into the United Utilities Innovation Lab. So we developed a system that fit nicely into that problem statement that James was just talking about. To give you some background on what we do, Vapor have developed software to automate the detection of issues in underground stormwater and sewer pipes by using AI directly on the inspection footage. So essentially the way it works is that we've trained deep learning models on thousands of examples of pipes and coupled this with computer vision techniques to produce a standardized, objective condition assessment and inspection report in a way that's easy to understand for quick decision making. So it's also hosted on the cloud so that we can keep the data all in one central location and that we can tighten up the turnaround time between the inspection footage being captured and a decision being made. United Utilities' involvement through the Innovation Lab was largely around sharing data with us to help us to further develop our models and accuracy and getting a deeper understanding of their processes and figuring out where our system could be used for optimization. United Utilities have also assisted with standards alignment and have been really driving the conversation for AI and pipes across the UK water industry. So since the lab, the ongoing developments that we've been refining with United Utilities to continue to close in on those requirements to meet the UK standards, but also to be able to identify issues for the developer services team who face a different set of challenges in the risks of adoption of new networks for the utility. So in being able to partner with United Utilities, some of the new developments we've been able to achieve is a higher overall accuracy in all feature detection with a faster turnaround time as well on our video processing. So we've been able to add extra classification outputs for richer data insights, such as things like detecting anomalies in water level for issues like dips, detecting low quality footage and loss of vision, and detecting the pipe material off the vision alone. United Utilities also asked us to develop several value add features to the web platform so that we could streamline that end-to-end process, which we're now trialing with the involvement of United Utilities contractors for CCTV as an intelligent contractor model. And the most recent thing that we're working on now is the automation of remediation actions. So once you understand the condition of the pipe, actually figuring out what you're going to do about it. So we're trying to make consistent and data-led decisions by this partnership. So by having the contractor involved in this project, combined with the instant objective remediation suggestions This has the potential to significantly tighten up that end-to-end process, which at the moment has way too many touch points for everyone. So there's a real opportunity to get a lot more data, a lot more value out of the CCTV inspection data than the traditional process allows. And our system is one of the tools that can be used within this process to reduce the time, resources, and money that can all be put to better use in this system. This will also give you then the ability to reprocess your historical footage. So that would include FastPass, and that you could bring that all of your data up to the same standard and provide insights that could be used for root cause analysis of failures from historical and for predicting for the future. So to put it simply, there are just too many people with glazed eyes on glass who are being used like robots in this process. And our system does those monotonous, repetitive tasks so that the people can do a faster review of only the things that need their attention and make better informed decisions without that volume of work that previously would have come with reviewing 750 kilometers of pipe inspection videos that James mentioned earlier. So yeah, this has enabled United Utilities to invest in the future of their wastewater networks by getting more value out of their existing resources. And together, we're keen to see the rest of the water industry challenge the traditional way of doing things and maximize the potential of the data you're already collecting. So, yep, that's us. Tom, back to you.
Thanks, Michelle. Thanks, James. I'm a bit of a sewer nerd myself, so I find that really interesting. A really good example of the innovation process of United Utilities, which those of us in the UK hear a lot about, and how successful it can be in promoting early stage startups. So yeah, really good presentation. Thank you very much to both of you. Thank you for staying up, Michelle, as well, or waking up early, whichever one.
No problem.
Okay, so our final presentation is from William Geel. He's a business manager for digital and municipal services at Veolia. I'm sure I don't need to introduce Veolia to most of you on this conference, because you'll all be familiar of the countries they work in and the activities they do. William himself is specialising in commercial innovation and service development, and leads innovation across Europe and Africa. He's going to talk to us a little bit about some of the projects they've deployed, I think specifically around wastewater treatment. William, if you're ready, I'll hand across to you.
Thanks a lot, Tom. Thanks for the introduction. Hi, everybody. A real great pleasure to be with you this afternoon. And my objectives for the next couple of minutes is just to share some practical examples of how we have delivered value by adopting real-time advanced optimization. But I guess a sensible place to start is, before we consider what the next generation of wastewater looks like, we need to perhaps pause and focus on the problems that we're actually trying to solve. And in doing so, I suggest that we kind of need to focus on not only those direct challenges, but also the indirect challenges that we face that perhaps aren't as clear to us, such as some of the cultural challenges concerning operational silos within our organisations, and challenges also in the demographic of our operational workforce, for example, that in my opinion will play a significant role in shaping the way we manage wastewater in the future. And it's then that we can consider what part advanced optimization has to play in meeting these challenges. But always with new solutions bring strategic questions, and hopefully in the case studies I'll discuss further some of these challenges around how we level ROI, how we practically scale and implement and deliver success from real-time optimization. So kind of what's Veolia's experience in this space? Well, the real-time optimization journey started for us some 20 years ago, back in the early 90s. And I guess like all good ideas, it started with a challenge. And that challenge essentially was twofold. It was, how do we help our customers optimize energy associated with their aerobic treatment processes? And also a little bit more specifically, how to control biological phosphorus removal in a smarter, more efficient and more stable way, which certainly for the UK market currently, phosphorus removal is certainly a significant challenge. And over those last 25 years, we've developed our capabilities, and Aquavista plant now includes over 60 individual optimization modules that span the entire wastewater treatment process. So that includes both treatment assets and also the wastewater network. But key for us has been to ensure that that Aquavista remains technology agnostic. At its heart is around performance, process performance improvement, and not really an instrumentation solution. And as well as hopefully this will come out in the case studies I'll share with you, is modular and scalable. So can be deployed individual modules to achieve a specific outcome, or combined as part of a more systems thinking approach, as James was making reference to a minute ago, a systems thinking approach to how we optimize assets. So first example I'd like to share with you is a wastewater treatment site southwest of Copenhagen. Primary challenge for this customer was frequent sludge escape during stormwater events, and therein the manual interventions associated with rectifying this issue. So our initial solution focused specifically on meeting this target. Now, under max flow conditions, by optimizing the plant in real time, we're able to increase the hydraulic capacity of the plant by over 80%. But as well, importantly, thinking about those indirect challenges I mentioned at the start, is the control of this plant now happens completely automatically. So again, if we reflect slightly on our operators, the manual interventions required for controlling these stormwater events has dramatically reduced. So with that business case established and the ROI was just under 2.5 years, we then worked with the customer to enhance that system and grow the system to meet OPEX and other performance drivers. As you can see on the right hand side of the slide there, the plant has a relatively tight total phosphorus permit, and to achieve this, the traditional approach was to increase chemical dosing. But what we did was we deployed our package of biological phosphorus removal features, as well as chemical dosing features, to reduce the chemical dosing at this site by 60%, whilst at the same time promoting and controlling biological phosphorus removal. Now that sounds great, but the key thing to take away from this is that this plant was not designed for biological phosphorus removal. So there is no anaerobic volume within the plant. So what we're doing with real-time optimization is we're utilizing that existing volume, but we're creating anaerobic phases to enable biological phosphorus removal. And for the next example, we stay in Denmark. This is a Danish utility called Blue Colding. This time it's not a single site, it's an entire utility, so treatment plants and networks that are optimized using Aquavista plants. So similar to the previous case study, we started small and we expanded the solution over time. Starting off, we're focusing on energy reduction and improving stability at their main wastewater treatment plant. We took the customer on that journey, taking sort of baby steps, so to speak, in terms of building the confidence within the customer business, and particularly the operators, that this is a solution that they can work with. And then over time, as you can see in the solution timeline there, we expanded to include smaller satellite wastewater treatment plants and also the network. And this time the specific aim was managing stormwater, and in particular, reducing the financial penalties associated with combined sewer overflows. Now the business case here is really interesting, and I think starts to articulate the power of real-time optimization. By challenging the traditional solution of simply building additional capacity, we were able to reduce the CapEx budget of this solution by 2 million euros. By essentially combining real-time optimization with a small amount of additional capacity. So I'm not saying that the real-time optimization solution completely eliminated the need for capital investment, but it certainly reduced that budget. And we're still continuing to work with Blue Colding now to deploy further advancements that we're developing all the time as part of our R&D process. And just one I'll share with you is the developments we've been focusing on in terms of model predictive control. Now, we've been developing model predictive control on 4 sites at full scale. So they're not small scale, these are small scale, full scale sites. And Blue Colding is one of these utilities that we've been working with. Now, in a nutshell, what model predictive control enables us to do is to predict future loadings of a plant with greater accuracy and with a longer horizon. So we're able to adapt set points to handle fluctuations in a more stable and a more efficient way. And crucially, in terms of real-time optimization, one of the challenges that's often leveled at real-time optimization is reliability of data. Well, a big focus for us in terms of model predictive control has been to how do we meet that challenge? So it also enables us to compensate for limited data or loss of data, as we can fill the gaps with our models between the data points and still perform at the highest level. So now we have the ability to continue to optimize with limited data, which helps to meet some of those challenges. So I hope those examples have been interesting and helped to articulate with real-time optimization how we can meet both those direct and those indirect challenges, and how we can make digital transformation tangible and scalable. And I think that's often a key challenge is, how do we deliver something that's tangible? And also the importance of taking that long-term view and ensuring that what we deploy today is fit for purpose in the long term. So thanks very much for your attention, and back to you, Tom. Thanks.
Thank you, William. Really interesting and really good to see a real movement towards real-time optimization rather than perhaps the more traditional decision support methods. I was about to ask a question. One of my fellow panelists has just answered the question whilst I was about to read it. So we do have, I think we're scheduled to finish it in about 3 or 4 minutes time. So I've got a couple of questions which I'll put to the panelists. We'll go in a similar order. So I'll start with Javier. Javier, which area do you think is most in need of innovation for wastewater networks management and so on?
In my opinion, the most pressing areas is the integration and development of information and communication technologies to achieve process optimization. In other words, an approach to management in real time.
Excellent, thank you. Yeah, so it's quite a similar theme to I think we heard earlier as well from the water side, how we can bring things together. Same question to Perttu, if you can.
Yeah, this is actually a good question. We were talking about this in one of the roundtable talks as well. And my opinion is that the IoT measurements in the network in quite harsh environments, no electricity and bad connections is something which is really challenging. And we already have the technology, but it's also about us utilizing these technologies and taking them even further.
That's a really good point. So that's something I think I noticed in your presentation as well, Perttu, that being able to make use of data we already have, that we've already got in better and smarter ways is really important. So trying to break down data silos and bring all that data together and produce insights. So that's really good. Thank you.
Yes, definitely.
James, same question to you. What area do you think is most in need of innovation?
I think it's things we've discussed. So using the data that we've got and having a more holistic catchment approach to everything. So in terms of us not just treating it as a sewage undertake, but urban drainage as a whole. Something I'm really interested in is there's a project in Amsterdam at the minute. These are blue-green roofs and how that can help store water, so it's prevent surcharge in the sewer network. So this whole idea of a smart city or a smart urban drainage system collectively is something that I think in the future we really need.
Yeah, great. So I've noticed the United Utilities focus on systems thinking. So if you look at a holistic collection of water, transport of water and treatment of water, it fits really nicely with that kind of systems thinking. And I think the keynote from Jacobs yesterday I forget who it was, Bruce Chalmers, I think, where it really pulled out that kind of thought about how we can bring everything together as part of one system. Michelle, what do you think is the most area pressing for innovation?
Yeah, I would say all of the above, but also to say we're kind of moving in a digital age now, so we're collecting a lot of data, but actually being able to like filter that data, store that data, centralize that data, and get our insights out of that data. That's one of the biggest challenges. So yeah, I would say data centralization and interpretation.
Yeah, definitely. And we do a lot of projects where we use data, existing data, and probably most of the effort, most of the difficulty is how to bring that data together in the first place. So how can you bring information on systems which are sometimes built 20 or 30 years ago? How can you bring all that together with real-time data from IoT instruments? It's not easy. So yeah, it's a really good point. William, same to you.
Thanks, Tom. I think for me, actually, what we need to focus on is providing the right kind of environment to adopt innovation. I think, over the course of the last couple of days and continue tomorrow, that, lots of great experience out there, lots of great new solutions, lots of great technology that's been innovated. But I think we need to be careful not to ignore innovating in the commercial environment as well, because actually you can have a great solution, but it can often be a big barrier to adoption if actually the commercial environment within which we're trying to propose it doesn't actually harness that innovation. And I think that's a key area. And often if you think about the water industry of old, very much the commercial model is around sort of design and build. Actually, as we move into the digital environment, that commercial model might not be completely fit for purpose. And I think that's where we need to see some innovation as well.
Yeah, no, really good point, and I think it links back into what James and Michelle spoke about, the Innovation Lab from United Utilities, and that's certainly some I've seen is a really great way of bringing through new ideas and new technologies, and fits nicely with the talk about build back better yesterday as well. How can we move quicker in a changing environment with changing tools? So no, really interesting. Thank you, everybody. I think that's exactly on time, so I will hand back to the other Tom if he's available.
Actually, I'm going to be taking over for you, Tom, although you guys can call me Tom if you'd like to. Nice to meet you all.
You don't look like a Tom. I'll hand back to you, Nadia. Thank you.
Thank you so much, Tom, and to all the panelists. I really appreciate the discussion on next generation wastewater management and also how we can bring this all together with innovation. So we are going to be going on a short break. We will be coming back at 15 after the hour. During this time, if you've been stepping out as needed, we are going to be showing another sponsor video. And this one, I believe, is from Hawk. So thank you for everyone, and we'll see you after the break.
Okay, everyone, thanks for joining us after the commercial break. And we are now into the final session for the day. And it's my job to introduce our moderator, and we are going to prove that this, the phrase of the graveyard shift does not exist in SWAN. So, in fact, many of you will know our next moderator. He's a man who needs no introduction at all. He's a Chief Executive Officer of KWR Water Research Institute based in the Netherlands. He was speaking about digital long before it became fashionable, and to many, he is the godfather in the best possible way of hydroinformatics. So ladies and gentlemen, I'm pleased to hand over to the man, the myth, the legend, Professor Dragan Savic. Over to you, my friend.
Thank you, Tom, and welcome everybody to this last session of the day. We're talking about network challenges, and I have 4 experts who I'm keen to hear from. Jan Hoyer, Philip Van Colly, Sebastian Otero, and Ramon Dolz. Jan is from Wittens Drinking Water Company in the Netherlands. Philip is from the Water Group, water company of Brussels. Sebastian Otero is from Esbio, from Chile, another water company or water service provider. And Ramon Dolz is from Baseform, and they are in the supply chain. So without further ado, I would like us to get into this panel. Each and every panelist will have to introduce their topic, and then we will ask questions at the end. But before that, I would like to share just a brief invitation with all our water utility colleagues to participate in a short, less than 15 minutes, up to 15-minute survey about smart water. You will see it's quite interesting, and we are supported by SWAN, IWN, Water Europe. So please, please make your contribution to this survey, and you will hear the results through the SWAN when we get them from everybody. So as I said, we're now moving on to the panel, and the first presentation is from Jan, and I believe it's recorded presentation, so we can hear that and then ask question at the end when all of our presenters finish. Please.
At Wittens, we started several projects concerning water flow and water quality in the distribution network, from production to DMA. Since the residence time in the water in the distribution network is rather short, water quality hardly changes from distribution to DMA. In this case, water quality parameters, such as electric conductivity, are mainly used to check and calibrate hydraulic models. However, what's happening inside the DMA is far less known. Since we are using highly mazed networks to increase redundancy, our hydraulic model suggests that water might circulate quite a long time before being consumed by our households. Therefore, more detailed learning what's going on inside the DMA is needed. Previous experiments with water quality sensors placed at households suggest a minor but distinct worsening of water quality considering oxygen, color and turbidity. Since we do not use chlorine, it is expected that bacterial growth within our mains is changing water quality. In order to study these components, Wittens constructed a smart DMA called Westeinde to get better insight in flow and water quality aspects inside the DMA. This DMA contains approximately 1500 connections. About 95% of these connections are equipped with a smart meter. Besides a few shops, these connections concern mainly households. This slide shows the DMA of Westeinde. The yellow-green diamonds are representing the smart meters. The smart meters are also equipped with a temperature sensor. This DMA does have 3 connections with our main distribution system, shown as the red dots. These 3 connections are equipped with flow and pressure sensors, as well as a conductivity sensor. Inside the DMA, we placed one multi-parameter water quality sensor. And at another location, we placed a prototype of a conductivity sensor at a household which is combined with a smart meter. This DMA is situated in a transition zone between two production locations with different water quality. Previous research in other parts of Friesland, where these two water types do mix, we often observe elevated bacteria counts. And to get more insight in the detailed flow patterns in this highly mazed network, we want to check the calculated flow patterns with the use of conductivity sensors. At the end, we want to optimize the flow pattern in this DMA by closing and opening valves at specific moments in order to minimize the maximal retention time in this system. The arrows show the flow direction in this DMA during normal situations. At that time, the DMA is mainly fed by water from Noord-Burgum. And during periods of high water use, during warm weather for instance, the flow pattern reverses. High water use during warm weather, for instance, the flow pattern reverses. Water is now entering from the south and is mainly fed by the production location Spanneburg. This slide shows the average lowest temperature at the water meters during a warm day. Blue squares represent colder water in our mains, the red squares warmer water. It can be seen that at the entrance of the northeastern side the water is the coldest, which is expected from the models. Also at the south side water is colder due to inflowing water. Farther within the mazed network, some areas are quite warm, up to 5 degrees warmer than the coldest locations. This indicates a long residence time and thus older water and possibly water with lower water quality. These are the locations we want to take grab samples to analyze bacteria. However, the COVID-19 outbreak prevented us to take grab samples at the households so far. Conductivity sensors are proven to function very well tracking water flows within our network. Since the costs of installing a conductivity sensor with telemetry is quite high, we are experimenting with conductivity sensors combined with smart meters. This gives us the opportunity to transmit the conductivity value together with the signal of the smart meter. This picture shows the first installed prototype. This prototype was quite large. 9 smaller versions are ready to be installed. However, again, the COVID-19 outbreak prevented them to be placed. This figure shows the observed values from this meter. At moments that a household is not consuming water, the temperature increases and the conductivity value is not representative for the water in our mains. Also, the conductivity signal is getting very noisy at these moments. So we have to correct the conductivity values and keep the values that are measured during water consumption, as this figure shows. The remaining small dips in the conductivity value are due to the formation of air bubbles in the sensor. The new ones do not show these dips. After installing all conductivity sensors, we are able to trace every drop within our network. We need these measurements since we want to control the water flow by opening and closing valves to minimize the water residence time and optimize water quality. By using these sensors, we can check and calibrate our hydraulic models and verify these models as a digital twin. Our next steps. This week we are starting with taking grab samples at fire hydrants since we are not allowed to take grab samples at households due to COVID-19. In a short time we are going to place actuators at valves to remotely control water flows, and as soon as we are allowed to, we are going to place the remaining electroconductivity sensors. Any questions left?
Dragan, you're still muted.
Dragan, yes.
I got caught again, guys. You know, these older people, they shouldn't be doing this. Anyway, we all kind of learned our lessons of digitalization, I guess, in the last few months. Okay, since I've got the floor now, maybe I should ask that question to Jan. This is a reminder to everybody through the chat. Please ask questions and direct it to a particular panelists, and I'll be more than happy to pick on a few and ask them. Jan, I was particularly impressed by some of the work that you've been doing with these water quality sensors and assessing the time of residence within the network. Can you tell us of an example? And I know of one, but I want to hear from you when you were actually looking to compare how the model works and what your sensors were doing.
Yes, well, we have a rather big network in the northern part of the Netherlands, where we have a production plant in the southern part of the province, and the main city is more to the middle. So based on our models, we expected that the travel time between the production plant and the city of Leawater would be somewhere in the range of 36 to 48 hours. And that's where we based all our thinking about. But then we used water quality sensors to assess the actual travel time, and it turned out to be less than 24 hours. So apparently there were differences between reality and our models, which we weren't able to verify totally based on flow and pressure, but we needed water quality sensors to get these insights.
Thank you. I mean, that's what the innovation from these digital tools come in. It's a water quality sensor, and you used it for completely kind of different purpose in that case, to update your model velocities within the model and everything else. By the way, Jan has background in hydrology, but he is the innovation manager at Vitens, and he is responsible for quite a lot of innovation, R&D, and data science within the organization. Jan and everybody else, now we will move to the next presentation, and we'll come back to you with questions from our participants. So our next speaker is Sebastian Otero Gleisner, who is the network manager at SBO in Chile. And he is, for the last 6 years, he has been leading the non-revenue water reduction plan and defining solutions to optimize the performance of water sewage networks. He's also a member of the utility advisory group at SWAN. So today he is presenting the challenges of reducing the impact of service interruptions and how they as a company faced it at SBO. Sebastian, floor to you.
Thank you very much. Hello, everybody. I will be telling you about our experience in SBO, reducing service interruptions. And first, I'll make a brief introduction. The water industry in Chile is mostly run by private companies. We have almost 100% of drinkable water coverage and wastewater treatment coverage. It is the only country in South America where you can drink water directly from the tap, and we have one of the lowest rates compared to other countries within the OECD, with a rate of around $1.2 per cubic meter. SBO is a private company, the second largest water and wastewater utility in Chile, providing services to around 20% of the population in an operation area that is similar to the size of England. That is around 3.5 million people widely spread in over 120 different cities and towns, with almost 10,000 kilometers of water networks. Chile is a very seismic country. In 2010, we had a very large earthquake, 8.8 degrees, and that caused a lot of damage to our infrastructure. And after that, we experienced a sharp increase in breaks and bursts, raising in around 4 years, almost 30% the service interruptions. We discovered that in average, for each pipe break, over 4 sectors were affected by service interruptions. This means that if we had, for example, a break in sector number 1, 3 other sectors were affected by service interruptions because of the lack of alternatives to keep the service running during the repair time. And by sectors, I mean part of the network with usually 100 to 300 customers that you can isolate with existing valves in case you need. similar to a DMA, but not with the metering. So in 2015, we started a plan to reduce the service interruptions. First, every break is now followed by root cause analysis that starts with very simple questions like, did we have other sectors affected by this break and why? Is it the first time that this pipe breaks? Do we have pressure problems? Do we have pipeline problems? And giving use to all the data we had, we are now defining the optimal solution to the problem that caused the service interruption to one or more sectors. Second, we changed our operational target. It used to be minimizing the delay in repairing every break, but now it is to minimize the customers affected by service interruptions, centering our effort in closing the right isolation valves. Additionally, we are increasing the use of clamps and other trenchless technologies to replace and repair pipes. Third, with the use of hydraulic modeling, we are improving pressure regulation in order to prevent new events and adjusting the network sectorization by replacing isolation valves that are in bad conditions and making pipeline interconnections to increase the resilience. The target is always to reduce the customers affected in case we have a new break near the same location. And finally, we are investing in monitoring and control such as pressure loggers and smart PRVs. So that's how every year we are investing in around 10 new PRVs. We are installing or replacing almost 200 isolation valves among the other actions. This way, the plan has achieved a significant reduction in customers affected by service interruptions. A better network sectorization has helped us minimizing the area affected by breaks, while a better pressure management has reduced the number of breaks and bursts. And as a result of that, our customers affected by service interruptions have decreased in over 60% in these 5 years. And the sectors affected by recurrent service interruptions, this means 3 or more service interruptions in 1 year, they have decreased in almost 90%. So now our next steps or challenges, we still need to reduce the size of our biggest sectors. We still have a lot of sectors with more than 300 clients. We have to reduce our repair times during pipe breaks, and therefore we need to have better information and support for the field teams, especially during big events. And finally, as conclusions, I would like to say that service interruptions, as we all know, have a big impact on customer service quality. So smart actions go beyond infrastructure replacement. That is why root cause analysis and data management are key to success. Operation adjustments have a significant contribution at a very low cost, but require high commitment of the field teams and support from the back office teams. And finally, with strong data analytics, the investment in infrastructure will be better prioritized, leading to much better results in performance, costs, and customer service. Thank you very much. Go back to you, Dragan.
Thank you, Sebastian. Very impressive results, very impressive impacts on your level of service provided for your customers. And I was very impressed, you know, Chile looks so small on that map of South America. When you compare it to England, it's really gives me an idea of the size of the country and also of the size of the service that you kind of provide in geographical region, very distributed. You showed 4 different types of actions, interventions to reduce the impact on your customer. Could you tell us a little bit more what had the most impact in your company?
Well, I would say that in our experience, the most important thing was that we started changing the way we were facing the problem. It was a simple way that didn't need an additional budget. This means, first of all, we changed the way our field operators were facing every pipe break, starting to change the target. They used to make all efforts to repair the burst as fast as possible, closing isolation valves as fast as possible, but not paying too much attention to the size of the area that was affected by the service interruption. Now they take a bit more time to study the case and identify the isolation valves they need to close in order to affect as few clients as possible. And during the event, when they find out that one of those valves is not working, then we schedule the replacement in order to avoid that next time we have again problems to isolate the area. And second, we started using all the data we had. I believe every utility has a lot of information, but not all of them are using it the right time. Are giving it the right use of all the valuable information that data contains. We started using that to make a root cause analysis and started making small network changes, such as I said, valve replacement or pipe interconnections to minimize the customers affected by pipe breaks. Excellent. I would say that was the main thing, the most important thing.
Yeah, so changing the objective and having the common objective understanding of those among your people was the key there. Thank you, Sebastian. We'll get back to you if there is time at the end of all the presentations. And I'll move now to our next presenter, who is Philip Ankoili. Philip is head of asset management, distribution and supply at the Water Group, which is the water company of Brussels in Belgium. He's been with the company for 15 years and they supply about 3 million people, I believe. And since 2018, Philip has been a head of asset management for the company, which is has the mission, or that newly created group has the mission to bring maturity of its asset management to the highest level. And he's also coordinating the non-revenue water program within the organization. Philip, over to you.
Okay. Thank you, Dragan. I have prepared some slides. Do I need to do something myself?
I don't think so. The organizers will put it up.
Okay, thank you. I will already start introducing the Water Group. Sometimes if you talk about Belgium, there is a slight misunderstanding between Brussels and Belgium. So it's a small country, but I will help you on that. So, well, the fact that our airline is called Brussels Airlines is not very helpful on that. Yes. But in fact, the Water Group is active, not in Brussels itself, but in the northern part of Belgium. And in that area, we are the largest if you look at network size. So we have some numbers here. I will go along these numbers. You see the number of 34,000. That's the number of kilometers of the network. And we have about 3 million customers, people who we supply with drinking water, and we have wastewater services. And that makes up about 180 municipalities. We have about 1,500 people working for our organization. Our mission statement is that we provide water today for the generation of tomorrow. So this sustainability is a main aspect of our mission and vision. And of course, innovation has an important place, is an important priority for our organization. Innovation together with being on the edge technology-wise. The last number that I did not explain already is our turnover. We have about 600 million euros turnover. And if you talk about asset management, it is unavoidable, in fact, the subject of non-revenue water. So that's why I will talk about that in the following slides. So I want to explain that our water system is under stress. I'm convinced that we are not the only water utility who is experiencing this situation. And we can explain this on the fact that we experienced prolonged droughts, periods of drought in the last several years. It was really unknown for the people here living that we have so much prolonged periods of drought. But together with that, we have experienced increased peak demand, even in seasons of the year where we did not see this before. This year in May, we had an extremely high peak demand, which is never seen of for our company. And well, in fact, it's not just this peak demand, but there is also a changing, there are changing expectations of end customers, which is of course related with changes in our society and technological changes. And of course, our business is asset intensive. So that's why we focus on the optimization of asset management. So we adopted a holistic action plan to reduce non-revenue water. In fact, in a time period of 3 years, we have the reduction goal to reduce the real leakage with about 50%. So really an important and fast reduction. And then in another time period of 4 years, again, we aim to reduce this by half. So really an ambitious goal. We do this, well, I will explain a little bit how we do this. We can do this so fast because we have a lot of best practices and experiences developed within the company that we are now scaling up, so to make sure that everyone in the company is working along these best practices. We also adopt the state-of-the-art technology on different domains, together with participation in research for new technology that is not yet available on the market. Okay, you can, yeah, sorry, you can go one slide back. So our holistic action plan, you see 7 action tracks, in fact. So 5 of these action tracks are focusing on leak reduction. And 2 of the action tracks are focusing on prevention. So if we look at leak reduction, we have the first track focusing on deployment of sensors in the network. Then we have better connectivity as a second track, which aims to transfer the data from the sensor to a centralized data warehouse. And the third track focuses on creating actionable insights based on this data. So we don't just need numbers, we need actionable insights for our operators. And that's what you can see in action track 4. The people use these insights to improve their leak localization processes. And then in the end, every leak needs to be repaired, and we need to get this process optimized so that the leak repair is with the correct priorities so that it is fast executed. Prevention focuses on 2 aspects. So action track 6 is working on improved pressure management. I will show something on that in one of the coming slides. And last but not least, we are also focusing on making the network replacement policy more efficient. There is no use in keeping on repairing leaks if there is a structural problem with the pipe. All this is combined, this action plan is combined with change management and communication throughout the whole organization. So on the next slide, you can see the end purposes or end goals we want to attain, which is less damage and service interruptions. That's something that Sebastian has been talking about also. We want to have a smaller number of leaks, as well as a better involvement of employees. So every employee has its own role and needs to be recognized and needs to know why they are doing their job, what is how they help the organization. We also want leak repair to be better planned, and of course our reduction goals will result in financial return as well as a sustainable image to outside the organization. I have two images that give some more insight in our actions. So here you see the area we are responsible for drinking water, and the different colors are the DMAs. That's about 400 DMAs, and you can see that there are some DMAs that are in yellow, which means that those DMAs are on this very moment in focus to make them smaller by installing more pressure and flow sensors. So we combine always flow and pressure measurement. I have another image which indicates some results on pressure management. So in the north of the province of Limburg, we were able to reduce the number of mains leaks, mains bursts, with about 40%, just by calming the network. So the average pressure has remained the same, but the pressure transients have been reduced with quite good results. Okay, so that was some insight on our approach for reduction of non-revenue water.
Thank you, Philip. Philip, just a brief question. In your bio, I found out that you've got a master's in cultural and development studies. Seldom we can see that with civil engineers, and you also have masters in civil engineering. So can you just tell us how do you find that balance between implementing all these technologies and change management within the organization that is required for it to be embedded within it?
Yeah, well, I think technology is what interests a lot of people among us. But if you want to create change and have results on a larger scale, you need to. It's fundamental that you are aware that there is a lot of people involved, and so there is a lot of attention needed on change management in order to make every operator involved, to motivate them, and by addressing this change on this way, you also create a kind of grassroots motivation and way of working. So there's a lot of ideas and a lot of knowledge available in these operators, and if you can untap this resource, it's really powerful. So for me, it's the combination of the two that is really a key for success. Yeah.
Absolutely agree with that. Thank you very much, Philip. Can I just say, Jan was very efficient in answering all the questions online, so I will suggest any questions that you pose please look into the chat. Our next speaker is Ramon Dolz. He is Director of Spain and Latin America at Baseform. He's an engineer with more than 20 years of experience in management and business development. And over the last 3 years, he's been with Baseform, and he's leading the growth of the organization, helping utilities save water and energy. So he will address how the combination of data generated every day and the technology can assist utilities in making better decisions. Ramon, over to you.
Hello, everyone. Thanks, Regan, for your introduction. And thanks also to all my colleagues, panelists, for their nice presentation. I would like also thanks to SWAN and especially to Amir and Shaina for inviting us to be here today. In fact, it's our first time here, and we are impressed by the quality of speakers, presentations, and discussions we've had, and expecting more tomorrow. Baseform is a software company based in Lisbon, Portugal, and it's a software for utilities, designed for utilities, and it's mainly addressed for managing water and wastewater networks. It provides comprehensive and actionable analytics to assist in the specific efficiency issues and key business outcomes. First, I would like to make a question, which is that you know that less of 1% of utility data is effectively used. And this in a scenario of growing sensorization and more data. I think one of the main challenges that the managers of utilities are facing today is how to deal with all that amount of data in an efficient manner. From Baseform, since the beginning, so from our roots, we thought that that challenge was also our challenge. And we developed our software not thinking on the data that it was required, but on the utilities' existing data, the sensorization and IT systems that were available, which is different in any utility. And also we thought that that could be leveraged by public data sources, and that's what we did. Our software has several functionalities, but today I'm going to explain you how we predict failures in networks using the data that every day is generated in the utility. Because every day you generate lots of data in your utility, from your SCADA systems to your work orders, your billing system, laboratory analysis. All this data is in independent silos, and we gather everything in our software and we transform it in actionable information. In this case, many of you as water experts understand that the aging of pipes is one of the most challenging issues you have in your system, because the time is running against us, right? Against us, all of us. But also the experience showed us that sometimes when you renew a pipe that it's very old, maybe 100 years old, it's in a very good shape and it could be been there for more time. Meanwhile, pipes that are much younger are failing. Thus, the age and the material, of course, are factors we all have in mind for a pipe failure, also previous failures, but we thought that there should be other factors impacting the failure of pipes. With that in mind, we worked in our software to understand which variables influence the behavior of pipes. As understanding which pipes are going to fail first would be of the utmost interest for a water utility manager. That's what we thought, and that's what we did. First of all, our software connects to the real-time data from the utility. In this case, I'm showing you a monitoring system. We connect to the monitoring system to better understand leaks and bursts in the network. Our software is able to create predictive patterns of flow and is able to detect deviations on this pattern that then are translated into repairs or other actions that are recorded in a more or less informal way in the utility. This is the first step because we see the network as a connected system, which is not isolated. The asset management is not isolated for the day of the day-to-day operational system, right? Then we add more information to data flows to combine this information with pressure or other information that it's available at the inventory level, as can be installation dates, diameter, materials, and all the relevant information available at the utility. And on top of that, we add layers from public sources like weather or buildings or traffic or railway roads, all the information that the utility with its experience can think that can impact the failure of pipes. Then we can generate results that our customers can understand better how the pipes are going to fail. What we do is that we don't have a determination of life for each cohort of pipes, like we could say that the steel pipes can last 80 years or whatever. But what we do is that we have a failure rate for each individual pipe on the network today and in the future. And this is dynamic because it's feeding from the daily information that comes from the utility. With the results from our software, our customers can also better understand how pipes age. Deterioration curves like the one I'm showing you now are generated and can be grouped by any variable in the analysis. For instance, if you group it by material, it can help utility managers to make better decisions in analysis life cycle costs of using one or other materials for a renewal. For instance, in this slide, you can see the failure rate evolution in number of failures per kilometer for a specific material in a specific network in one of our customers. The blue line you see there is the failure rate of a pipe in the following years since it's installed. So on the left you have the installation date, and on the right you have it's 100 years. You see the evolution of the failure rate for this material. In yellow is the failure rate of the same material when a pipe fails once. And in red, you have the failure rate evolution of the material when the pipe fails more than once. This helps to understand that the asset management is not a static activity, but is influenced by the daily activity and changes over time. Because for a pipe that has never break, you see that it's the blue line, and then if it breaks one, it's the yellow line. Finally, the combination of the different data sources give us the ability to give metrics that help our customers to prioritize renewals based on their goals, as can be water loss by breaks or any other indicator that the utility uses. The important aspect here is that the combination of failure prediction with the consequence of failure for each pipe can finally give a risk value for each pipe that help our customer to optimize their CapEx. Our results in our we have now 200,000 kilometers of pipes for about 20 million users, people served. Our experience is that our customers are multiplying by more than 10 the efficiency of the renewal plans. So this is what I wanted to tell you today. Back to...
Excellent. Thank you, Ramon. That was very, very impressive. We have 2 minutes. So before I ask you that one question that I can and expect a short answer, I have to thank all of you for today's brilliant presentation. Lots of innovation, lots of mixing of cultural change within organization and technology. It's not just the technology, is it? So for you, Ramon, the classical question, do we need more data or do we need more quality data? Everybody is complaining we don't have the data, but when we have the data, it's not enough quality, yeah?
Yeah, Dragan, actually that's a very good question. And as I told you, we don't come from the IT scenario, we come from water, and we knew which were the challenges the water utilities have when implementing a solution like ours. So from the beginning, we thought that we should be able to generate results with the existing data. So when you don't have many data, maybe you think you don't have many data, but at the end there's a lot of data. And our software is able to fill the blanks. So we use our big data, all the data we have to fill blanks. And also we are able to reconcile repositories of information. So imagine you have your work orders in an Excel sheet with an address number. We can assign the failure to the pipe in the GIS and things like that. So you don't need a specific amount of data or quality of data. Of course, the better the data and the more data you have, the better the results, but you can start with your current situation.
Great, great. Well, thanks everybody again. Sebastian, Philip, and Jan, don't forget that to fill that smart water survey, and everybody else from different utilities, please do that. And also, there are lots of questions already answered, few that are left. So please, panel members, try to answer those questions. We're going back to Tom and Nadia.
Again, thank you so much. Thank you to the panel for this wonderful discussion and the end of day 2. I want to thank everybody for being here. And again, thank you for doing what you do. A couple of reminders. If you haven't downloaded the conference app, what is taking you so long? Get on there, start networking with people, because tomorrow we're going to have a breakout networking session. There's a fun poll there too. I would love to see if everyone can answer it, because it seems like only the same amount of people that took the poll yesterday joined today, and I know that can't be the case. We're always going to aim to be better. And when you're on the conference app, and in addition to looking at who you want to network with tomorrow, stop by the virtual booths. Our sponsors have put a lot of time and effort into showing some of these innovations that are being discussed here during the sessions. And with that, I would like to turn it over to Tom for some closing remarks before we all go about our days or evenings or mornings.
Thank you, Nadia. Thank you, Dragon. Thank you all panelists and moderators. Another fantastic day of discussion, collaboration. We hope you've managed to get out of the day what I have. But we haven't finished yet. Tomorrow, we're going to start back at 2 p.m. British Summer Time. We have a keynote address from Megan Glover, who's the co-founder and CEO of 120 Water. And then we have 2 very, very strong panels. First one moderated by Amir Peleg, who many of you will know, the founder and CEO of Takadu and behind SWAN as well, on defining a successful utility digital transformation. We have more breakout networking, and then last but not least, a panel hosted by Fred Royan from SWAN. He's a SWAN council member as well as Frost & Sullivan, on digital sustainability and resilience in the new normal. It's going to be one hell of a panel to close things off. And we also have the SWAN Leadership Awards. So it's the last day, but it's action-packed, lots going on. So make sure back here, 2 p.m. British Summer Time tomorrow. So everyone have a well-deserved beer or glass of wine or even water, whatever you're drinking. And we'll see you back here tomorrow. Thank you.